Now, for the introduction, using the HW481 sensor in our project. The HW481 is a traditional MOSFET LED drive module designed to control RGB LED, strip or other high-power LED lights. It is specifically built to handle the higher current and voltage than standard Arduino output, making it suitable for 9-volt LED strip or external lighting system. The module contains three N-channel MOSFET, each controlling one color channel, red, green, and blue. It receives PWM, pulse within modulation signal for the microcontroller like Arduino. To adjust the brightness of each channel by combining the different brightness level green, red, and blue, the module can produce the wide range of color. Power is provided externally, typical 9 volt, and the module acts as a switch to control the LEDs based on the PWM signal for the Arduino. This project demonstrates how to use HW481 LED module to create customizable RGB lighting controller by an Arduino Uno. This can be applied in decorative lighting, mood light, or home smart home ambient light. Okay.
We move on to the methodology. For this project, we use several components to build the SOS signal system. First, we use the HW481 LED module, which controls external LEDs using MOSFETs. A MOSFET is an electronic switch that lets the Arduino control the LED safely without overloading it. Next, the Arduino serves as the main controller that sends signals to the LED and the buzzer. We use a breadboard to make the circuit connections easier, and a power source in case the LEDs required more current than the USB port could provide. A USB cable was used to upload the code and power up the Arduino. We also added a buzzer module to produce the SOS sound and a push button to activate or stop the circuit. And finally, all components were connected with a common ground, and when the program runs, pin 13 controls the LED while pin 12 activates the buzzer, creating the SOS alert. So that's all for the methodology part.
So, code of practice ISO 128. ISO 128 is an international standard that defines the general principle used in presenting technical drawing. It ensures that drawings are clear, consistent, and universally understood, no matter which country or industry they are from. Next, ISO 128 covers two main aspects. First, line and line type. It specifies different types and thicknesses of line used in drawing. For example, a continuous thick line shows visible edges. A dashed line represents hidden edges, and a long dashed dot line marks the center. These variations are important because they help us distinguish different features on a technical drawing clearly. Second, view, cut, and section. This part defines how different views, such as orthographic projection, as well as cut and section, should be represented on a drawing. It ensures that every drawing follows the same convention, makes it easy for engineer and manufacturer to interpret correctly. In summary, ISO 128 acts as a rule book for technical drawing. It standardizes the visual language of engineering design so that a drawing created in one country can be easily understood everywhere in the world.
Now, for the result, we use the AutoCAD in 3D modeling. This is the sensor HW481. This is a buzzer. This is a push button. And this is a freezing application circuit design using freezing. This is a breadboard view. This is a schematic view. And figure 7 and 8 3D viewer for the PCB. And figure 9 is the connection of the PCB.
So, for the discussion, throughout this mini project, our team faced several challenges that require us to find our own solution. Here, I will explain the three main difficulties we encountered and how we managed to overcome them. First, we face limited component availability in FreeZine library. Although the FreeZine provide many components, some specific parts we needed for our system were not available. To solve this, we downloaded custom component from online source such as GitHub and add them manually using FreeZine editor. This allows us to continue our project without being restricted by the library limitation. Second, we had unfamiliarity with software tools. Some team members were not used to working with tools like KiCad, which slowed down our circuit design process. To overcome this, we helped each other learn the basic function of the software. Through collaboration and teamwork, everyone become more confident and efficient with the tool. Lastly, we encounter limited team communication. Because of the different schedule, it was hard to us gather for the discussion, which delay our progress. So we solved this by organizing online meeting to share update and discuss the problem in detail. This improved our communication and made our team much more effective.
For the conclusion, throughout the development of this project, our team gained significant technical knowledge and practical experience in electronic, programming, and collaborative project work. One of our main achievements was the successful design and testing of an emergency alert system capable of the detected loud sound through the HW481 sensor and triggering a visual and audible SOS signal. This accomplishment demonstrated our ability to integrate hardware and software effectively using the Arduino platform. Beyond technical expertise, the project strengthened important ethical and professional qualities. Effective teamwork played a vital role as we divided tasks according to each member's strength, promoting efficiency and cooperation. The project also encouraged creativity, especially in designing the SOS signaling sequence and circuit layout. Overall, the project not only improved our technical competence, but also deepened our understanding of the teamwork, communication, and ethical engineering practice. Last but not least, for the first, I recommend to fully utilize the RGB capability of the HW481 module. For the recommendation, the HW481 is a 3-channel offset LED driver for the RGB LED strip, which is red, green, and blue. The current setup appears to only use a single channel for a basic on-off flash controlled by Arduino pin 30. For the action, we can modify the circuit and code to connect the Arduino pins, which is 9, 10, and 11 to the all 3 RGB channel of the HW481. For the enhancement, program the SOS signal to flash in a different color, which is red for emergency and white for the maximum visibility, by combining a RGB channel or have a multicolor fade in the background, making it more comprehensive and attention-grabbing 7-color flash system. Next, we can improve circuit documentary clarity. For the recommendation, the FreeZine view, which is a breadboard and schematic, are basic. In schematic view, in the figure 6, we can use a standard electrical symbol for the Arduino, which is a microcontroller chip, HW481, and buzzer or LED, making the circuit topology clear for the electronic engineering.